Voyager to turn its camera back towards Earth, and it's what basically amounts to Earth's first ever selfie. And that picture was taken, and there was this pale blue dot.
With its latest finding, Voyager 1, the world's farthest spacecraft, has once again caught the attention of both experts and space fans. The spacecraft has been giving back information since it was launched more than 40 years ago, in 1977. This information has changed how we think about the farthest areas of the solar system and beyond. Neil deGrasse Tyson, a famous astronomer, recently shared an amazing discovery. Voyager 1 has seen 775 unknown things moving through the vast space between the stars. This finding brings up deep questions about the world and the possibility of things we haven't seen before that are just out of reach. After leaving the Sun's heliosphere in 2012, Voyager 1 moved into interstellar space, which is now more than 14 billion miles away from Earth. This important event was the first time that people went outside the safety of our solar system. Voyager has been a kind of sentry since then, exploring the strange world between the stars. The new discovery of these strange objects is one of the most interesting events in its quest. What are these things? Are they leftovers from long-ago cosmic events, pieces of space junk from faraway systems that have gotten lost, or something completely new? Neil deGrasse Tyson's discovery has made scientists very interested again and has led to a lot of discussion, since it could change a lot of what they know about the universe. Voyager 1 wasn't specifically made to find things in space. It was meant to study the outer planets and the edge of the solar system. But its set of devices, especially its cosmic ray section and plasma wave system, have been very helpful in learning about how charged particles and magnetic fields interact in space between the stars. The 775 unknown objects may have been found because of small changes in the plasma environment or because cosmic rays bend as they pass by or interact with these objects. The objects have not been seen directly because the Voyager cameras were turned off years ago to save energy, but there is strong proof that they exist. The sheer size and complexity of interstellar space are brought to light by this finding. For many years, most people thought of space beyond the solar system as being empty, with only the odd star or planet to break up the darkness. But this new discovery points to a different reality. Space is full of moving objects, some of which may be the remains of old star systems. Some of them might be things that have never been seen before. These might be made up of dark matter, pieces of planets that have gone astray, pieces of dead stars, or even icebergs floating through the galaxy. Each option gives us a new way to look into things and learn more. One of the first questions that came up after this finding is where these items came from. There could be pieces of matter thrown into space from other star systems when stars die violently. When a star explodes in a supernova, it can send shock waves through the space around it that throw matter far away from where it came from. Over the course of billions of years, some of this junk may have moved into the areas that Voyager 1 is now exploring. It's also possible that these items come from faraway galaxies, were pushed through intergalactic space by unknown forces, and are just now arriving in our galaxy's area. It seems that space, even beyond the heliosphere, is more active and full of people than was thought before 775 items were found. The fact that these items could be very different is another interesting thing that this finding means. Some scientists think they might be a variety of celestial things, from simple pieces of rock to very complicated structures that formed in conditions very different from those in our solar system. This might help us learn more about how matter acts in places where stars don't affect it. Finding unidentified things in space between the stars could lead to the discovery of new types of matter or physical processes that can't be seen in our solar system. It has also been suggested that some of these things might not be natural but rather man-made. Even though there is a very small chance of finding alien items in interstellar space, the discovery of so many unidentified things naturally makes people think. Some people think that these might be the remains of long-gone alien societies, with their equipment now floating around in space. The public still thinks about this idea, but Tyson hasn't really thought about it. He's been more interested in the science prospects. Finding man-made things in space would have huge effects, maybe even earth-shattering effects. It would mean that intelligent life has lived in other parts of the world and that we are not the only ones. So far, the evidence points to natural objects, but the sheer number of them makes people wonder about the different kinds of things Voyager 1 might be seeing. Even if these things are natural, they might be different from anything else that has been seen before. They could provide new information that could challenge current ideas of how planets form, stars die, and galaxies are put together. The finding by Voyager 1 also shows how limited our existing technology is for exploring space between stars. Although Voyager has done a lot, it is still using technology from the 1970s, which makes it hard for it to directly view these things. There may be a need for more trips in the future with more advanced equipment that can make more thorough studies of interstellar bodies to follow up on this finding. The discovery of these objects shows how important it is to keep exploring space. NASA and other space agencies are already working on the next generation of interstellar probes. A mission meant to study interstellar matter could change the way we think about the world and maybe give us real answers about what these things are made of. The find also makes us think about the future of space travel in general. As people try to reach beyond our solar system, the fact that there are unknown things in outer space creates both problems and chances. On the one hand, these items could make it harder for future spaceships to find their way through interstellar space. On the other hand, they might provide great chances for scientists to study things. A journey to study one of these things up close could give us information about their makeup, structure, and where they come from that has never been seen before. This could one day help people find new materials or energy sources that are good for everyone. The finding by Voyager 1 also shows how big interstellar space is and how little we still know about the areas between the stars. Even though astronomers have been studying the universe for hundreds of years and space travel has been going on for decades, we are still only beginning to scratch the surface of what is out there. The discovery of these 775 objects is a warning that space is not empty, but full of riddles that have yet to be solved. With each new find, scientists learn more about how the world works. Voyager 1's most recent find is no different. As it goes farther from Earth than any other man-made object, the spaceship keeps pushing the limits of what people know. Another interesting thing about this finding is that it might have something to do with dark matter, the mysterious material that makes up a lot of the universe's mass. Some astrophysicists think that these mysterious items might be made of dark matter, which would give scientists a unique chance to study this mysterious substance up close. If these items really do show that dark matter interacts with normal matter, it could be the first direct proof that dark matter exists and acts in space between the stars. Dark matter has been one of the biggest puzzles in science for decades, so this would be a huge step forward in our understanding of the universe. The fact that these items were found in outer space, where stars don't have much of an effect, makes us wonder how stable and long-lasting they are. Are these things temporary and going to break down or fade away over time, or are they there to stay in outer space? Finding the answer to this question could lead to important new information about how matter forms and changes in the galaxy. These things might be a new type of celestial body that has never been seen before if they are stable. If, on the other hand, they are only temporary, studying how long they last and what happens to them in the end could help us understand how interstellar space works. Voyager 1's discovery of these unknown items also shows how important the probe is still today. Voyager 1 is still one of the most important science tools ever made, even after more than 45 years in space. Its mission has already changed the way we think about the solar system by giving us new information about the outer planets and the edge of the heliosphere. Now, it's giving us information about the structure of interstellar space that has never been seen before. This discovery shows how smart the engineers and scientists who built Voyager were in making sure that it would keep finding new things even as it travels farther away from Earth. The huge number of unknown items found is one of the most interesting things about this find. It's not a small deal that 775 things have been found in space between the stars. People used to think that space was mostly empty, with only random cosmic dust clouds and the odd asteroid or comet moving around. However, Voyager 1's results called this idea into question, saying that space may be much more full of unknown things than was thought before. What this realization means is mind-boggling. For example, these objects could point to a group of galactic junk that hasn't been seen before. This could shed light on events or processes in the universe that have never been seen directly. Many new findings are still being made by Voyager 1. This shows how huge and complicated interstellar space is. We have learned a lot about space over the years, but it is clear that we have only begun to scratch the surface of what is out there beyond our solar system. Astronomers and astrophysicists may have to change how they think about interstellar space after finding the unknown objects. For example, if outer space has more matter than we thought, this could change how we think about how matter acts on a cosmic scale. It might change how galaxies form and change over time, how stars are born and die, and even how different parts of space talk to each other. Each of these things holds a secret that needs to be solved. Scientists are excited to look at the data that Voyager 1 sent back to learn more about these things, but because the ship was only able to do so much, we still have more questions than answers. Are these things small and thick, or are they spread out and look like clouds? Are they made of metals, rocks, ice, or something else strange? The answers to these questions could have huge effects on how we understand not only the local interstellar world, but also astronomical processes in general. If these things, say, have elements or combinations that aren't found very often in our solar system, they could tell us a lot about how the chemical makeup of different parts of the universe is different. One of the more interesting ideas that this find has brought up is the idea that some of these things may be connected to the idea of rogue planets. A rogue planet is a body in a planetary system that no longer orbits a star but instead drifts freely through space after being thrown out of its system. The number of rogue worlds in the galaxy is thought to be in the billions or even trillions. Could some of the things Voyager 1 saw be pieces of these kinds of planets or even whole rogue planets? Even though this is just a guess, it would be a new step in the study of planets. Rogue worlds have been very hard to study up until now because they are so far away and don't have a light source nearby. Being found by Voyager 1 could be the first step toward naming and studying these things up close. The finding also makes people think about what other projects might be able to do that Voyager 1 did. The spaceship is a great accomplishment, but it can't do everything because of technology from the 1970s. With better tools on future trips, we might get a much better idea of what these things are and how they behave. A journey made just to study the space between stars would be able to measure these objects in ways that Voyager 1 can't, looking at their makeup, density, and speed in much more detail. A journey like this could even carry tools that would let people see these objects, which would be the first time people have had a direct view of the strange things that live in interstellar space. This finding also makes us think about how we study space in general. Planets, moons, and other objects in the solar system have been the center of most space research efforts up until now. But the fact that these 775 objects were found outside the heliosphere says that the areas between stars, which were thought to be empty and boring before, are full of things we know about. This makes it possible for a new type of space research that aims to learn more about the areas between galaxies. In the future, missions might not only look at specific places like planets or moons, but also at the huge stretches of space that link them. The finding made by Voyager 1 also has huge effects on how we think about how galaxies move and interact with each other. It is possible that interstellar space is full of more things than was thought before. This could change how galaxies grow and how matter moves around in them. One example is that these things could help move stuff between star systems over very long stretches of time. Things moving through interstellar space could be pulled in by the gravity of stars or planets, bringing new materials into star systems. Cosmological accretion is the name of the process that is thought to help make new planets and stars. But the fact that so many items have been found in interstellar space says that this process may happen more often and be more complicated than was thought before. The finding also brings up interesting questions about where these items came from. Are they the remains of old star systems that have long since broken apart, or are they made of something completely different? Some scientists think that these atoms might be made of stuff from the very beginning of the universe that hasn't been affected by the things that have changed our solar system. If this is true, then studying these atoms could give us new information about how things were in the early world, right after the Big Bang. Astronomers have long tried to figure out how the world began, and this finding would help them a great deal. There's also a chance that these atoms have something to do with the strange phenomenon of cosmic rays. High-energy particles called cosmic rays move through space at almost the speed of light. They come from supernovae and black holes that are far away. Voyager 1 has been studying cosmic rays in space between the stars for many years. Some experts think that these unidentified items may be linked to the cosmic ray environment in some way. They might be places in space where cosmic rays hit matter, or they might even be places where cosmic rays come from. If this is true, these items could tell us important new things about how cosmic rays are made and how they move through space. It's also possible that these things are connected to dark matter, which can't be ruled out. Dark matter is one of the biggest puzzles in modern astronomy. It makes up a big part of the universe's mass, but can't be seen or found using normal methods. There is some scientific thought that these unidentified items might be a rare type of matter that reacts with dark matter in some way. If this is true, then studying these things might help us learn more about dark matter and how it affects the framework of the universe. For us, this would be a huge step forward in knowing one of the most basic parts of the universe. Voyager 1 found 775 items that had not been seen before. This has implications for the future of human space travel. As people look to the stars and dream of traveling between galaxies, the appearance of these items shows how hard things will be. It was once thought that interstellar space was a huge, empty nothingness, but now we know that it is full of possible dangers. When going through interstellar space, any ship will have to avoid hitting these objects, which could be very bad. This may lead to the creation of new technologies that can find and avoid things in space, which will make sure that future trips are safe. On the other hand, these things also show a chance. All of them could be explored, and they could all be seen as stepping stones to deeper parts of the world. As we get better at interstellar travel, teams could be sent to study these things up close and use them as stops on longer trips. These things might even have useful things for people who want to fly to space in the future, like water, ice, or other things that can be used for power and to stay alive. This finding by Voyager 1 not only adds to our scientific knowledge, but it also sets the stage for future space travel. The trip that Voyager 1 is still on shows how powerful human creativity and interest can be. The spaceship has been going since more than 40 years ago, and it is still helping us learn more about the world. It found 775 new things in outer space, which is just one more example of how much we still don't know. Every new bit of information Voyager 1 sends back makes us think of new things, questions, and beliefs. As we continue to explore the universe, the lessons we learned from Voyager 1 will help us find our way through the unknown and find out what secrets lie beyond. The discovery of these items is not the end of the story. Instead, it is the start of a new phase in space travel. We will learn a lot more about these objects and what they stand for as experts look at the data and plan new trips that will follow Voyager 1's path. They might help us find new kinds of matter, new things happening in space, or even new ways to think about how the universe started. No matter what happens in the future, Voyager 1's finding is a strong reminder that the universe is much bigger and stranger than we think, and there is always more to learn. As Voyager 1 begins its first ever journey into the deepest parts of interstellar space, 775 unknown things passing by have made us think very differently about how we see space itself. People used to think that the space between stars was mostly empty, with only a few cosmic dust particles, gas clouds, and energy particles here and there. This new information questions that idea. Instead, it looks more and more possible that the area beyond the heliosphere, the sun's protective bubble, is much more active and full of matter than was thought before. These recently found objects each offer different science possibilities, and the sheer number of them brings up new questions about the makeup and nature of space between the stars. Finding out where these 775 unknown items came from is one of the hardest things for experts to do as they try to understand them. Space is always changing. Stars are born, live, and die in amazing supernova blasts that send huge amounts of matter into the universe. Matter is always being mixed up and moved around in the galaxy because of this process. That being said, what methods are responsible for making these particular objects? One possible reason for these objects could be pieces of old star bursts that have been spread out over billions of years in interstellar space. Material from these objects may have moved very far and gone through many star systems before Voyager 1 found it. Even though this theory makes sense, it makes me wonder about other things. If these things really are pieces of supernovae from the past, then why haven't more of them been found by other instruments? Due to the large distance between the stars and the low density of the material between them, it might be hard to find these things with binoculars on Earth or in space. Since Voyager 1 has been beyond the Sun's heliosphere and into completely unexplored territory, it has a unique view that could help find these long-lost cosmic travelers. The spacecraft's ability to pick up on small changes in the medium between stars could give us important information about how these things interact with the rest of the universe. Some experts have also said that these things might not be the remains of stars that died a long time ago, but rather a completely different type of cosmic event. For instance, these objects could be pieces of rogue planets, which are planetary bodies that have been thrown out of their original star systems and are now wandering the sky without a connection to anything. Rogue planets are thought to be pretty common, but they are very hard to find because they don't have a home star, which makes them almost impossible to see with normal telescopes. The things Voyager 1 found could be pieces of rogue planets or even whole rogue planets. If this is true, it would be a huge discovery that could change how we think about how planets form and move around in the sky. It's also possible that these unidentified items are made of strange materials that aren't usually found in our solar system. The interstellar medium is very far from being affected by stars, so it may contain materials that are hard to find or not present in parts of space where stellar radiation is strong. This could include types of matter that were made in very harsh conditions, like the cores of neutron stars and black holes, or when galaxies were violently forming. If even a small portion of these 775 items are found to contain exotic matter, it could give scientists a chance to study the most extreme physical processes that happen in the universe's most powerful and violent places like never before. Being able to find these strange materials would not only help us learn more about how matter acts in harsh situations, but it might also be useful for people. In the past, technology progress has come from studying new materials. If Voyager 1 finds items made of materials that have strange properties, like being very hard, superconducting, or resistant to radiation, it could lead to more study into new technologies that use these properties. For example, future spaceships could be made of materials that naturally can handle high amounts of radiation. This would allow people to explore more dangerous parts of space, like the areas near black holes or neutron stars that have a lot of radiation. The finding of Voyager 1 also brings up important questions about the future of space travel and the tools and technologies that will be needed to learn more about these objects. Even though Voyager 1 gave us the first intriguing signs that these objects might exist, it is limited by technology from the 1970s and the fact that its cameras were turned off years ago to save power. Future trips with more powerful instruments and the specific goal of studying interstellar objects could completely change how we think about these objects' makeup, motion, and behavior. These kinds of projects could have high-tech spectrometers, particle detectors, and even image systems that could take pictures from deep in interstellar space. The idea of sending a new spaceship into space between stars brings up a lot of interesting technical problems. One of the most important is the need to create propulsion systems that can hit speeds between stars and keep working for decades or even centuries. Chemical power systems like the ones used in today's rockets are not good enough for such long journeys. But as power technologies like ion engines, solar sails, or even nuclear fusion drives get better, it might be possible to send projects much faster beyond the solar system. These propulsion technologies are still in their early stages of research, but Voyager 1's discovery of these unknown items shows that more money needs to be put into exploring the space between the stars. When studying things in interstellar space, there are big science problems to solve in addition to the technical problems. The sheer size of space and the difficulty of finding the exact locations of these things is one of the main problems. Even though Voyager 1 has found these objects, not much is known about their exact lengths and paths. Future projects will need to come up with new ways to properly track and locate interstellar objects. They might use advanced sensors or gravitational lensing to find tiny changes in spacetime that these objects cause. Another hard problem for scientists is to figure out how these things interact with the medium between the stars. Space is not empty, it is full of charged particles, magnetic fields, and cosmic rays that go all the way through the galaxy. What effects do these objects have on the space between the stars, and what effects do the stars have on these objects? According to readings from Voyager 1, these objects may be making small changes to the plasma environment they pass through. The reactions between these objects could teach us a lot about the features of both the objects and the material between the stars, giving us hints about the conditions that exist there. There are also possible effects on our understanding of the bigger structure of the galaxy that could come from finding these things. Individual objects in interstellar space are interesting on their own, but they may also be part of a larger network of matter in the galaxy that is linked by cosmic currents and gravity. If these atoms are leftovers from long ago cosmic events, then their spread out location in interstellar space might help us understand what happened in the galaxy in the past, similar to how Earth's geological formations show us the history of our world. Scientists could find trends that lead to past supernovae, stellar migrations, or even galactic crashes by looking at where these objects are in space and how they are moving. The finding of 775 unknown objects could also help us learn more about how the universe evolved on a much bigger scale. Even though we have a good idea of how galaxies, planets, and stars grow and change over time, we still don't know much about the stuff that lives between galaxies and stars. These things could be the building blocks of bigger structures in the universe, or they could show how matter is recycled between galaxies and stars over the course of cosmic time. We might learn more about cosmic cycles and how matter moves between different scales by studying these things. This would also help us understand how the universe has changed over billions of years. One more thing that could be looked into is what part these items play in how stars and planetary systems form. Voyager may first have found pieces of protoplanetary disks, which are clouds of gas and dust that form around young stars and eventually turn into planets. If this stuff got away from the gravity of its parent star system and is now moving easily through interstellar space, it could tell us a lot about how planets form in the early stages. Scientists could look into this stuff to learn more about the chemical processes that happen when planets are being formed and how different types of planets, like gas giants or hard planets like Earth, are formed. The search for life beyond Earth has also been changed by the finding of these items. There is no evidence from Voyager 1 that these objects are directly connected to life on other planets, but they are part of a growing body of proof that the universe is much more complicated and varied than we thought. Organic chemicals, which are the building blocks of life, are known to exist in interstellar space and could be in some of the items. If even a small amount of these items contain organic matter, it could be more proof that the building blocks of life can be found all over the world. Also, the discovery that interstellar space has more life than was thought before makes us wonder if other technology societies could have launched their own spaceships or probes that are now drifting through space like Voyager 1. Even though this is just a guess, finding unknown items naturally makes people wonder where they came from. Could some of these things be remains from alien societies that are either long dead or still active? At this point, there is no proof to back this theory. However, the discovery of so many unknown objects serves as a reminder that our understanding of the universe is still very young and there is still a lot we don't know.
2 spacecraft outside of our pale blue dot have made groundbreaking findings and consistently illuminated the planet both inside and outside of our system. The explorers have traveled throughout the whole solar system, exploring previously unexplored regions of the vast, starless emptiness. Scientists are pressing the alarm button after seeing something amazing today. What have they discovered then? What prospects does space exploration have? Come see what Voyager discovered at the solar system's boundary that surprises NASA, the start of history. Without examining the Voyager's origins, it is hard to discuss their significance. In an era characterized by rapid technological development and groundbreaking scientific discoveries, NASA charted a new trajectory that altered our understanding of space. Two golden spacecraft, each around the size of a small bus, were developed in 1977 with the goal of expanding human knowledge outside of our atmosphere. The longest road trip in human history was about to begin for these twin explorers, Voyager 1 and Voyager 2. As scientists and engineers completed the Voyager spacecraft, the excitement at NASA was evident. In addition to being aesthetically pleasing, their slender bodies shone with gold to shield their fragile instruments from the harsh environment of space. In order to solve the secrets of our solar system, Voyager 1 and Voyager 2 were equipped with a variety of cameras, spectrometers, and other scientific tools. The initial idea was straightforward: a brief 5-year run past Jupiter and Saturn to gather data and take pictures. However, these daring spaceships had different plans. After flying by Saturn's breathtaking rings and Jupiter's whirling storms, Voyager 2 rose to fame in the cosmos. It proceeded to visit Uranus and Neptune, two frozen giants, becoming the first spacecraft to do so. Scientists were amazed by the images it returned. Neptune's violent black storms in 1989 and Uranus's bent rings in 1986 revealed to us places we could only imagine. An even greater goal was the aim of Voyager 1. This tireless explorer burst through the bubble of our solar system and into interstellar space in August 2012, something no human-made object has ever done before. Imagine it as stepping out of your backyard and into an uncharted wilderness. Scientists were so taken aback that they double-checked their data for a full year before making this historic announcement in 2013. These spacecraft contained the most cutting-edge technology available at the time, which made them genuinely unique. In addition to instrumentation that could measure anything from magnetic fields to microscopic particles in space, each Voyager had greater processing capability than the first personal computers of the 1970s. Most impressively, they were made to withstand radiation levels that might quickly damage a smartphone and temperatures cold enough to freeze nitrogen. Numerous surprises have come to light during their travels. They found the first active volcanoes we had ever observed outside of Earth on Jupiter's moon Io. They detected solar winds that no one even knew existed, discovered odd spokes in Saturn's rings that shouldn't be there, and discovered unidentified rings surrounding Jupiter. When the internet was merely a pipe dream, most phones still had rotary dials, and digital watches were the latest technological advancements. These spacecraft were constructed. Nevertheless, they continue to function, continue to return data, and continue to provide us with new insights into our cosmic neighborhood. As humanity's most distant creation to date, Voyager 1 is in the lead, with its duplicate trailing closely behind. Together, they have transformed astronomy textbooks, unraveled long-standing space riddles, and helped us realize how vast and magnificent our solar system really is. Their radio signals, traveling at the speed of light, now take more than 22 hours to reach Earth since they have traveled so far, and they are still traveling. What started off as a small 5-year expedition has grown into the biggest space adventure in human history, a 45-year odyssey that has permanently altered our perception of our place in the cosmos. The question then becomes, how can they connect with Earth from such a great distance? Let's investigate. System of communication. A beautiful dish antenna is the foundation of Voyager 1's communication system. Voyager 1's dish is more than a meter wide, in contrast to the small ones employed by residential satellite systems. It is sensitive due to its size, and it is extremely directional due to its tightly regulated shape. The high-gain antenna could actually cover an area about half the size of Pennsylvania if it were pointed at a target on Earth. The Voyager 1 spacecraft uses two distinct radio frequencies, 2.3 gigahertz and 8.4 gigahertz, to transmit communications to Earth. The message must be transmitted at a slightly lower frequency, 2.1 gigahertz, when Voyager 1 gets it from Earth. These are very effective frequencies in the vacuum of space. They are optimized to be even more effective than the Apollo astronauts' trusty space radio. The signals that the spacecraft transmits begin as a meager 20-watt emission, which is equivalent to a standard refrigerator light bulb. These messages have become the most insignificant of waves, far less energetic than a whisper in a silent room, by the time they reach our planet. However, NASA's massive missile dishes, which are 230 feet wide, can still pick up what is essentially gibberish coming from the Voyager spacecraft. Voyager 1 contains a digital tape recorder with a capacity of about 67 megabytes to fill the massive gap. That would be enough to carry roughly 15 songs on an average phone. However, until you play the type of music found on the Golden Record, music cannot truly help us grasp who we are and where we're from. Voyager 1 is probably the most remote tape player in existence because it is still operational and sends data back from a distance of more than 13 billion miles. Each signal from Voyager 1 takes more than 22 hours to reach Earth, which is enough time to make 2 trips around the planet. The Mars rovers, in contrast, can ping Earth and receive a response in a quick 15 minutes. The modest exchanges that keep this spacecraft the furthest from home, connected to its builders, require patience and timing, which are required for every communication with Voyager 1. This cosmic discussion relies on NASA's Deep Space Network. The network contains what could be regarded as the solar system's 2 best ears. Antennas make up these ears. There are 2 different kinds of antennas, the 230-foot diameter antenna and the 112-foot diameter antenna. The 2 types of antennas together are sensitive enough to detect signals 1,000 times weaker than what a human could hear with a local FM radio station. These detectors are now so sensitive, thanks to modern technology, that they might theoretically catch signals from space probes located many light years distant. If the signals weren't somehow enhanced to an energy level several times higher than what we currently receive from Voyager 1 and 2, the key question is whether they could accomplish this. Astute power management is necessary to keep Voyager 1 connected to Earth. The spacecraft uses nuclear batteries known as radioisotope thermoelectric generators to produce its electrical energy. An RTG just continues to operate until it runs out of usable power, much like a regular flashlight dims before giving up. But unlike a regular battery that eventually gives up the ghost and stops working, these power sources gradually lose power. When Voyager 1 was launched, its 470-watt power source was sufficient to fully illuminate 4 incandescent light bulbs. Today, the spacecraft runs on less than 300 watts, despite less sunlight. However, even that figure is deceptive, since the heaters that maintain some of Voyager's fragile electronics utilize electricity that is dangerously close to the 300-watt limit when combined with the power needed by the operational instruments. The command team's first task is power management. Despite these efforts to save energy, Voyager 1's supply is still dropping at a rate of roughly 4 watts annually. The mission's engineers must constantly devise new strategies to increase the remaining power, and most crucially, to sustain the connection with Earth because of this gradual decline. Their pioneers have accomplished a great deal thanks to their sophisticated communication networks. The accomplishments of the explorers, Voyager 1 has continued to travel since its inception and is currently 14.6 billion kilometers from Earth as of August 2022. At the moment, it is traveling across space at an incredible 17 kilometers per second. Voyager 1 continued to travel at an incredible speed after entering space. In the strange realm of interstellar space, Voyager 1 is our sight and sound. Here, in what is essentially a micro-graveyard for the solar system, it is returning data on things we never thought existed. Strange data, inexplicable magnetic fields, and what scientists are referring to as plasma tsunami waves, a peculiar type of cosmic rays that shouldn't exist, are being returned by the still operational Voyager 1. We are learning more about what is beyond our heliosphere, about the extreme edge of the solar system, and about the interstellar medium as Voyager 1 gets further away from our solar system and its planets. Voyager 1's surroundings are not what we expected. It is a mixture of various charged particles that were left over from star explosions that happened millions of years ago, rather than being vacuum. We are only now starting to understand the stories these particles tell of dramatic and turbulent cosmic events. Perhaps the most significant discovery made by Voyager 1 was concerning our solar system. Returning to its current location, it is providing us with a view of the heliosphere, a massive bubble created by the solar wind that our sun emits. The spacecraft has shown that the pressure of interstellar space causes this bubble to be compressed and dented rather than being a perfect spherical. Its surface is a wavy, uneven sheet. It dips downward toward the closest star, Proxima Centauri, and bulges somewhat in the direction our solar system is moving through the galaxy. But we are only at one end of its vast surface area. Despite being relatively close to us, the next solar system has a half-billion-year history. Even though Voyager 1 has been working for an exceptionally long time, long as many of its engineers have been alive, it doesn't show any symptoms of aging. Every second, it's traveling another 17 kilometers into the vast unknown, further and deeper into the deep annals of space, and therefore establishing its position in the cosmic human history. In some way, each signal it returns makes itself increasingly more important, a new turning point in the history of human frontier exploration. So have you ever pondered how a device constructed in the 1970s manages to remain flawless in the most hostile environment imaginable? Let's examine the specifics. A marvel of engineering, the Voyagers are among the most durable spacecraft ever constructed by humans. They are not your typical spaceship. Building anything that is meant to withstand the toughest environment in the cosmos requires a great deal of effort and consideration. First, let's talk about power. The engineers of the Voyagers recognized that solar panels, which are used in most spacecraft, would not function in the darkness outside of Saturn. Instead, they gave it 3 nuclear batteries called RTGs. The same process that keeps the Earth's core hot is used in these incredible power plants to generate electricity from the decaying plutonium. The initial power output of each RTG was 470 watts, which is roughly equivalent to 4 brilliant light bulbs. However, Voyager 1's handling of the harsh conditions of deep space demonstrates its true genius. Special gold foil that reflects heat and radiation is used to wrap its outer shell. Inside, it features 3 different computers that can check each other's work. The others notice if one makes a mistake. That's more sophisticated than a lot of modern aircraft. The brain of the spaceship is quite effective. It uses 64 kilobytes of memory, which is less than one contemporary digital picture. Nevertheless, this tiny computer keeps its antenna pointing toward Earth all the time while controlling 11 distinct scientific instruments. It's similar to balancing on one foot, playing chess, and solving math problems simultaneously. In relation to instruments, each one is an engineering marvel. Single atoms flying across space can be detected by the cosmic ray detector. A refrigerator magnet might be detected from a mile away by the magnetometer because to its extreme sensitivity. Particles so thin that their combined ions would weigh less than a snowflake are measured by the plasma sensor. The communications system aboard Voyager is the main attraction. Its main antenna, which is almost as wide as a tennis court, can pick up radio signals that are as weak as a snowflake falling. Massive dishes in NASA's Deep Space Network, including one in California taller than a 20-story skyscraper, receive these signals when they reach Earth. Voyager 1 was constructed with longevity in mind. There are backup mechanisms for it. Its wiring is sufficiently robust to withstand micrometeorite strikes. Its computer code is also constructed in a unique fashion that allows it to continue operating even in the event that some of its memory fails. Even spare copies of critical systems that could be turned on decades later were considered by the engineers who designed it. The ability of Voyager 1's engineering to adjust to issues, however, may be its most remarkable feature. It simply switched to backup thrusters that hadn't been utilized since 1977, when its primary thrusters, which had been in use for 40 years, started to wear out. Voyager 1 continues its journey today, bringing with it the pinnacle of human ingenuity from the 1970s. How NASA's Voyager spacecraft steer. Clear of asteroids and black holes, Voyager 1 and Voyager 2 have traversed billions of kilometers of space since their launch to investigate the outer heliosphere and the solar system's periphery. However, the fact that they have not encountered catastrophic occurrences like asteroids and black holes during their extensive trek through this immense expanse of space is among the most enigmatic aspects of it. The intelligence and diligence of NASA's scientists and engineers are responsible for this outstanding achievement. The size of space and the many dangers it contains must be taken into account in order to appreciate the difficulty of this accomplishment. There are millions of asteroids, comets, and other objects in the universe, and many of them are fatal risks to spacecraft. Additionally, black holes are fascinating because of their powerful gravitational pull, which can draw in anything that dares to approach. How, therefore, did NASA accomplish this outstanding accomplishment? The utilization of particular design solutions, precise computations, and thorough preparation are the keys to the solution. As with every launch, NASA scientists calculated the Voyager spacecraft paths in a way that would assure they would not run into black holes and asteroids. Based on the known structure of the galaxy and the location of asteroids, engineers designed a path that would lead the spaceship past less populated regions of space. Additionally, gravitational slingshots helped with maneuvers, which were crucial to the Voyager expedition. The spacecraft passed near both of these planets at a right angle, changing course and gaining velocity from the gravitational pull of Jupiter and Saturn. NASA scientists were able to ascertain the gravitational pull that these formations exerted and ensure that their vehicle would not be in an unfavorable orbit thanks to this technique. The effectiveness and skill of NASA engineers are demonstrated by the fact that all of these gravitational slingshots were accomplished. Another element that was essential to the Voyager spacecraft's mission was asteroid avoidance. NASA took the following actions to lessen this risk. Conjunction analysis made it feasible to calculate potential collisions and stand the estimated asteroid approach. Controlling position made it possible to keep a safe distance from the asteroids in dangerous orbit. In this particular mode, NASA's Deep Space Network monitored the sun-pointed spacecraft's position and velocity data in real time, allowing for quick corrections if necessary. For the Voyager spacecraft, black holes posed a much greater threat. NASA used astrometry, gravitational wave sensing, and X-ray and gamma-ray monitoring to detect and avoid such cosmic occurrences. Space telescopes, LIGO, and other gravitational effect detectors were utilized to observe X-ray and gamma-ray activities associated with black holes. Black hole mergers were determined to be the source of these actions. The design elements of the Voyager spacecraft were also essential to their survival. While redundant systems guaranteed continuous operation in the event of component failure, radiation hardening shielded electronic components from cosmic radiation. Communication with Earth was made possible by high-gain antennae, which allowed for real-time navigational changes. Voyager 1 and Voyager 2 have now reached interstellar space, which is outside of our solar system after decades of journeying. They encounter fresh difficulties as they travel farther into the unknown. The interstellar medium, a tenuous charged particle field area, provides navigation difficulties. The spacecraft's course could be impacted by dark matter, an undetectable type of substance. The electronic components of the spaceship are also at risk from increased cosmic radiation exposure. The Voyager spacecraft are still advancing our knowledge of the universe in spite of these obstacles. Their extraordinary fortitude is evidence of both the limitless possibilities of space travel and human ingenuity. The end is near. Part of the journey is the end, and the indications point to the end of Voyager 1's experience. Over the course of its extensive space voyage, this amazing probe has traveled billions of kilometers and advanced human exploration beyond anything else in history. However, its power is now evaporating daily as it clings frantically to what remains of its reserves. There will be no more chit-chat from Voyager when the last of its few science instruments shut down. NASA engineers had to make the difficult decision to shut off Voyager 1's camera in 1990 after it had captured the now famous pale blue dot image. Earth appears as a small blue dot in the vast blackness of space in that picture. Everyone could see that the picture was historic. Though there isn't much more to do with the camera and it is using excessive power, further research has revealed that the Voyager 1 camera may have been capable of a bit more. Thus, the decision became quite clear. Its closing laps will resemble the last stages of an extended marathon. The remaining scientific instruments will gradually cease operations in 2025 and 2026. They are no longer able to function due to low power levels. Some instruments may continue to deliver their final messages from the cosmic frontier until the end of this decade. The final farewell may take place in the middle of the 1930s. The engineers and scientists believe that 2036 is the most likely year for Voyager 1 to return its final signal due to a number of technological issues. The voyage of Voyager 1 will not be over when it becomes silent. The probe will continue its journey across the Milky Way. About 1.6 light-years from where the spacecraft is now, in about 40,000 years, it will swing past a star in Ursa Minor called AC plus 79,388. Long after Voyager has ceased communication with Earth, its power supply will keep the golden record illuminated for another 5 billion years or so. Today's radio telescopes will still be able to pick up the signal that the spaceship is sending out. Scientists hope to meticulously gather crucial information about the solar boundary, the area where our sun's reach reaches out and interstellar space begins, before communication stops. What remains of Voyager 2 if Voyager 1 is reduced to a waning force? Let's explore that. Voyager 2 is still at sea. The second farthest man-made object from Earth is currently Voyager 2. Its mission has given us a plethora of information about the most distant planets and their moons of the Sun, as well as some of the most breathtaking views of the outer solar system. With the spacecraft still returning data from its most recent close-up of Neptune in 1998, the majority of that data, many of those images, came from a succession of amazing close-up flybys of outer planets. However, a straightforward command to an onboard computer to switch to an auxiliary power supply indicates an issue that the spacecraft's scientists never saw coming. At the end of 2023, a minor operational error occurred, which shifted Voyager 2's antenna by 2 degrees. In human terms, this is a minor alteration, but in the expanse of space, it is more than sufficient to cut off communication between the spacecraft and Earth. NASA's robust Deep Space Network tracking system has been unable to detect Voyager 2 signals for weeks. The spacecraft is not communicating with anyone, despite the Deep Space Network's remarkable technology and antenna arrays, especially a huge 70-meter-wide dish located in Canberra, Australia. Voyager 2 has been transmitting information from the area outside our solar system like a faithful informant. It has been measuring solar winds, magnetic fields, and cosmic rays, phenomena that, when comprehended, will shed light on the composition and dynamics of the cosmos. However, a significant issue with the spacecraft's communication system arose on October 9th. When optimism wanes, one searches for any indication that things could get better. NASA engineers are relatively convinced that Voyager 2 has not succumbed to being lost. It was hoped that the deep spacecraft CFT would still be functioning before it set an anticipated reset, and it has been operational for a very long period. There are a lot of things attached to the Voyagers that go beyond their journeys in space. Numerous space missions have provided us with priceless knowledge about the heliosphere, the far-off outer solar system, and the starry realm of interstellar space. They have learned a few things about the magnetic fields that characterize our cosmic neighborhood, cosmic rays, and the solar wind. The Voyagers have accomplished amazing things, traveling billions of kilometers over space and averting collisions with massive asteroids and black holes. Our perception of the universe is still shaped by these fabled ships. New design elements might be developed to carry on the remarkable legacy of these pioneers by closely examining their journeys. The Voyager 1 and Voyager 2 spacecraft, launched almost 50 years ago, are still orbiting the stars. When these experimental spacecraft eventually conclude their amazing missions, having traversed the heliopause and illuminated our solar system, humans will look back with nostalgia and anticipate the future of space travel with tremendous anticipation. What cutting-edge missions and technologies are ready to propel space exploration to new heights as we say goodbye to the Voyager era? Let's investigate the next stage in space and a glorious legacy. The Golden Record, which contains knowledge about humanity, our planet, and our place in the universe, is carried by the Voyagers as they drift into interstellar space. This symbolic act demonstrates humanity's curiosity and spirit of exploration while sending a message to possible extraterrestrial species. Carl Sagan and his team's meticulous curation of the Golden Record's contents captures a moment in time of human achievement and culture. Information about people, Earth, and our relationship to the rest of the universe can be found in the records that the Voyager spacecraft bring with them as they travel into interstellar space. This symbolic deed is a statement to the extraterrestrial species out there that human beings are explorative beings, not bound to their cosmos. Additionally, this will be humanity's way of telling the universe that it is amenable to possible cooperation with other life forms throughout the cosmos. Sagan and his working group have given the alien audience a glimpse of human accomplishments and culture through the Golden Record's fake message. NASA has developed new missions and technology for the next phase of space exploration beyond our solar system. They would make use of the Interstellar probe, a planned mission that is expected to be launched in the late 2020s and aims to travel farther into interstellar space. Other expanding projects include the New Horizons, which has passed by Pluto and is presently sailing through the Kuiper Belt region, indicating that NASA is not idle. After significant advancements in space technology, the next generation of spacecraft will be more effective. The improved nuclear power radioisotope thermoelectric generators, RTGs, will enable long-duration missions. Space travel is expected to undergo a transformation with the development of new propulsion systems, particularly fusion-propelled and light sails. The advancement of autonomous decision-making for spacecraft is another factor that will provide an extra advantage. Swarm robotics will allow several small spacecraft to cooperate with one another, while artificial intelligence will be fully integrated into spacecraft to enable autonomous operation. The commercial space industry is no longer a minor player in the process of space exploitation. Some of the largest companies in the sector, including SpaceX and Blue Origin, are actively developing better stations and maximizing the productivity and reusability of spacecraft. Additionally, cross-border collaboration will define future advancements of space research and exploration initiatives, like NASA's Artemis mission or ESA's JUICE, Jupiter Icy Moon Explorer, which will be essential in the next phase. Unquestionably, the legacy of the Voyagers will continue to serve as the ideal model for future generations of engineers, scholars, and space travelers. The next stage of space exploration will be greatly influenced by technological developments and cooperation among leading nations worldwide. As other long-term missions are established, the options will always be limitless, no matter what. Data just returned by NASA's Voyager 1 and 2, two of humanity's most ambitious space missions, has the potential to fundamentally alter our understanding of the cosmos. With ramifications that extend well beyond the realm of space exploration, what they have found at the very limit of our solar system is shocking the scientific community. The most startling discovery was a completely new magnetic field that was unexpected and might make us reevaluate how we perceive the entire interplanetary environment. Imagine this. Voyager has experienced a more powerful and intricate magnetic force than anyone had predicted. Despite the fact that the sun's magnetic effect was supposed to diminish as the spacecraft entered interstellar space. This surprising discovery is more than simply a scientific curiosity. It may have significant ramifications for our understanding of space travel, how to shield Earth from cosmic radiation, and even the nature of the cosmos itself. The consequences for humanity are profound, even though NASA is working feverishly to unravel this discovery. The interstellar magnetic field may lead to new exploration opportunities and perhaps survival tactics for space colonization, if it is as important as the Voyager data indicates. However, if it's a component of something more hazardous, something that hasn't been identified yet, we might be in risk. Given that SpaceX and other private space endeavors are about to create a human presence in deep space, this revelation comes at a perfect time. What implications does this new information have for our future, technology, and safety? The discoveries made near the solar system's edge have completely changed our understanding of the cosmos. Despite the Voyager missions having been humanity's eyes on the furthest reaches of space for decades. In 2012, Voyager 1 entered the wide reaches of interstellar space, now more than 23 billion kilometers from Earth and beyond the heliopause, the boundary of the sun's influence. However, it did not discover the serene emptiness that scientists had anticipated. Rather, it came upon a dynamic environment full of surprising events that have the potential to permanently alter the course of space travel. Cosmic rays, high-energy particles usually associated with the cataclysmic processes occurring in black holes and supernovae, were the most startling finding. For a long time, scientists thought that the solar system served as a shield, blocking off most of the cosmic radiation that enters space. However, as it passed through the heliopause, Voyager's detectors picked up a concerning rise in cosmic ray strength, indicating that this shield wasn't working as it should have. It wasn't a little occurrence. Rather, it was a noteworthy surge for which scientists were unprepared. Unsettling issues are brought up by this sudden shift in cosmic ray levels. Are we really ready to face the harsh realities of space outside of our sun's protection? Would future interstellar flights be at risk from these unanticipated radiation levels, especially for the astronauts who will travel far beyond of Earth's orbit? We haven't even thought about what else might exist in the interstellar medium. These cosmic rays could simply be a sign of a much more powerful, invisible force that lurks in deep space, and if so, humanity is dreadfully unprepared for them. These measurements are being intensively studied by NASA and other space organizations. But this is no longer merely a theoretical problem, as private space initiatives like SpaceX are moving closer to Mars and beyond. We're getting closer to putting people in space for long stretches of time every year. However, this new information suggests threats that no one had foreseen, forces in the deep unknown that could be much more dangerous than anyone had thought. Exploration into the furthest regions of the solar system is now a matter of survival for NASA, not just curiosity. All of our preconceived notions about space dynamics are being challenged by the extraordinary evidence that Voyager has returned regarding the behavior of the heliopause, the line separating interstellar space from the sun's protective bubble. However, the requirement for a more sophisticated strategic response grows as this revelation does. For many years, astronomers thought the heliopause, the point where the sun's solar wind and the interstellar medium meet, would be a clear-cut and well-defined limit. But the results of Voyager have shown something much more nuanced. Voyager has discovered strange magnetic and plasma fluctuations that conflict with existing models, rather than the anticipated slow decrease in solar wind. These sudden changes point to factors that we are still unable to fully understand, but which may have significant ramifications for both Earth's safety and space travel. It is now up to NASA, with its extensive network of specialized technology, to solve these puzzles. The agency is the sole organization qualified to lead this inquiry due to its exceptional position, which includes extensive experience, unparalleled data gathering capabilities, and advanced modeling tools. NASA is the only agency equipped to transform these surprising discoveries into useful information, from the ultra-sensitive equipment on board the Voyager spacecraft to the supercomputing capability utilized to process data in real time. NASA is unique, though, not only because of the data they collect, but also because of their approach to figuring out the real forces at work. They have a number of follow-up maneuvers planned to monitor the interstellar medium's changes and obtain more precise measurements of the magnetic fluctuations, so their job is far from complete. NASA intends to study the interactions between the heliosphere and the interstellar environment, using their knowledge of space physics in order to forecast the possible dangers of this novel behavior. In order to go further into the interstellar space that Voyager has only just begun to explore, they are already getting ready for a number of groundbreaking missions that will launch in the upcoming years. These unknown magnetic forces, however, present a formidable obstacle despite NASA's capabilities. Future space missions may be impacted by these pressures, potentially endangering the safety of astronauts traveling outside of Earth's protective bubble, if they are as strong and erratic as they appear. And what if the heliosphere's variations are only a sign of something much more serious that might have an impact on the solar system as a whole? Scientists are facing the horrifying realization that we might not fully comprehend the forces at work in space as a result of Voyager's recent discoveries at the farthest reaches of the solar system. Current scientific models are unable to explain the anomalies that the spacecraft's detectors have found in the gap between stars. These surprising interactions between the interstellar medium, cosmic dust, and solar wind suggest the existence of unidentified forces that may have significant effects on humanity's future. The results are especially concerning since they imply that our understanding of space, the protective bubble of our solar system, and the behavior of cosmic components is far from comprehensive. Inconsistencies seen by Voyager's instruments point to a complicated, hitherto unidentified interaction between cosmic dust particles and the solar wind that is interfering with the normal flow of matter at the solar system's edge. This might point to the existence of a hitherto unknown force that could have an impact on everything from how we safeguard spacecraft to how we perceive the interstellar environment in general. The ramifications are extensive on a worldwide scale. Future space missions could be seriously jeopardized if these unanticipated forces turn out to be more hazardous than planned, particularly those that are not shielded by Earth's magnetic field and atmosphere. These new findings make us think about how susceptible our technology and personnel may be to this unidentified cosmic menace, especially because NASA and SpaceX are both preparing long-term missions to the Moon, Mars, and possibly even beyond. However, the finding is not wholly unfavorable. By revealing the true nature of the interstellar medium, an understanding of these new forces could transform space travel and even pave the way for new propulsion techniques or strategies to shield astronauts from cosmic dust and radiation. Humanity may be ready for an era of interplanetary travel that was previously believed to be unattainable if scientists can use this newfound knowledge. The increase in cosmic ray strength at the solar system's edge is a high-stakes game that has the potential to change the course of human history, not just a scientific conundrum. Scientists are starting to face a terrifying truth as Voyager 1 and 2 return data indicating a startling rise in cosmic ray levels. The Heliosphere, which is supposed to defend our solar system, may not be as effective as we previously believed. Furthermore, this issue affects not only space travelers, but also life on Earth, technology, and potentially our ability to survive in space in the future. The powerful radiation from far-off stars and cosmic events may infiltrate our solar system more deeply and maybe reach Earth if the heliosphere's shielding effect is insufficient. Nevertheless, there can be drawbacks to this ongoing data transfer. One of the potential drawbacks is the dependence on the spacecraft's communication system for vital information. The spacecraft's power source is anticipated to run out by 2025 or so as its power stores continue to dwindle. Data transmission back to Earth might be seriously hindered. The spacecraft is already running on a little amount of electricity, keeping its instruments operational using the remaining nuclear power source. A major lapse in the data collection process could result from the system's failure, depriving scientists of vital knowledge at a crucial moment. Already, Voyager's journey into uncharted space has exceeded all expectations by providing previously unheard-of detail on the unexplored areas of the interstellar medium. For scientists who believe they grasped the limit of our solar system, however, the spacecraft's deeper exploration of the emptiness reveals more puzzles than answers. In the enormous void between the stars, what precisely is out there? Even though Voyager is returning useful data, it's still unclear what it's seeing, because what it's seeing contradicts all of our preconceived notions about interstellar space. Scientists have expected a peaceful, empty emptiness in the region beyond the solar system. Yet this is far from reality. Actually, anomalies that point to the existence of hitherto unidentified forces and bodies have been picked up by Voyager's instruments, including changing magnetic fields and odd radiation patterns. Researchers are frantically trying to come up with answers for these unanticipated communications, with objects that weren't even supposed to exist. The possibility that Voyager has come across unknown interstellar objects, or possibly a completely new kind of cosmic body, something that our existing sensors and models have never been able to detect, is among the most intriguing. This might be the discovery of something completely new, perhaps an as-yet undiscovered kind of energy or matter. However, if these discoveries are accurate, they may alter our perception of the universe's fundamental structure. The possible advantages and hazards for humanity's future in space follow. Now, the crucial question is, how can we get ready for what lies ahead? Would these unidentified bodies be a danger to upcoming space explorations, or may they be the secret to expanding humankind's reach into space? What else might be lurking in the icy blackness if Voyager's sensors are detecting interactions with entities we never even knew existed? Nevertheless, there is hope despite the anxiety of the unknown. A new era in astrophysics and space research may be opened if Voyager can carry on sending this type of data. The answers to questions that have baffled humanity for generations may lie in this new realm. Could this unanticipated connection with interstellar objects reveal gaps in our knowledge of space and put humanity in a more vulnerable position than we ever thought? Or could it lead to discoveries that usher in a new era of exploration? One concern still stands as Voyager continues its journey into the unknown. Are the forces it is encountering a warning of a cosmic peril we are not ready for? Or could they be a hint of something far bigger and darker outside our solar system? The stakes have never been higher. What Voyager discovers next may determine the direction of space travel and even our technologies. When it hits its boundaries, what happens? Will we encounter an unthinkable calamity or discover a new era of exploration? Voyager 2, which was launched by NASA in 1977, is among the most amazing space exploration accomplishments in human history. The spaceship is still sending data as it moves over the wide reaches of space more than 40 years after it was launched. What has it seen during the last 40 years? Because Voyager 2 has no intention of ceasing to satiate human curiosity, the human search for knowledge and desire for more about the solar system and the universe continues. We're heading to the edge of the solar system, so fasten your seatbelts. Crossing the heliopause. To put it simply, let's discuss the heliopause. The heliosphere, the bubble that the sun forms around itself, is made up of charged particles known as the solar wind. The interstellar medium, which is made up of particles from stars and other astronomical sources, is where these particles eventually meet particles from outside the solar system after traveling deep into space. The heliopause is the point at which the solar wind is no longer powerful enough to push against the interstellar medium. It resembles the edge of the sun's bubble. In November 2018, Voyager 2 crossed the heliopause for the second time, after its twin, Voyager 1. The heliopause is the line where the interstellar medium, or substance that fills the space between stars, and the solar wind, or charged particles released by the sun meet. Voyager 2 saw a dramatic decrease in solar wind, particle density, and an increase in interstellar particle density when it passed this limit. This verified that the spacecraft had left the heliosphere, the bubble-like area where the sun's effect is most noticeable. Measurements of plasma density. When Voyager 2 passed through the heliopause, one of its unique instruments was still operational. The electrically charged gas in space, known as plasma, was measured. In contrast to the plasma inside the heliosphere, Voyager 2 discovered that the plasma in interstellar space was denser, because it gave scientists a better understanding of the environment outside the sun's influence. This was a significant finding. Because Voyager 2's plasma instrument was operational when it reached the heliopause, scientists were able to obtain direct measurements of plasma density, unlike Voyager 1. The interstellar medium is denser than the solar wind, as evidenced by the notable rise in plasma density observed by Voyager 2. Our knowledge of the transition zone and the relationship between the heliosphere and interstellar space has improved as a result of this data. Observations of magnetic fields. High-energy particles known as cosmic rays are produced when stars explode and other significant galactic events take place. The sun's solar wind serves as a shield inside the heliosphere, limiting the quantity of cosmic rays that can reach us. Voyager 2 discovered much more cosmic rays after it passed over the heliopause, demonstrating how the heliosphere shields everything within it, including Earth. The magnetic field near the solar system's boundary was also measured by Voyager 2's equipment. It's interesting to note that the spacecraft saw that the interstellar magnetic field's direction resembled that of the sun's, indicating some degree of connection between the two. This discovery opened up new scientific possibilities by casting doubt on some preconceived notions about the boundaries of interstellar space and the end of the sun's influence. Energetic particles and cosmic rays. Voyager 2 saw a significant shift in the behavior of cosmic rays, which are high-energy particles that come from outside the solar system, As it moved into interstellar space, the solar wind partially protects the solar system from cosmic rays inside the heliosphere, but Voyager 2 experienced a greater intensity of these particles outside the heliopause. This reaffirmed the heliosphere's function as a shield against cosmic radiation. The dynamic nature of the boundary. The heliopause is a dynamic and changeable zone rather than a static limit, as demonstrated by Voyager 2's observations. The breathing effect is caused by the heliosphere's expansion and contraction in reaction to solar activity. These results imply that the boundary is far from uniform and highlight the intricacy of the Sun's interaction with the interstellar environment. An interstellar space window. Voyager 2 moved into interstellar space after passing through the heliopause and started examining the characteristics of the interstellar medium. In contrast to the solar wind's hot, low-density plasma, it found a chilly, dense plasma environment. These measurements give a unique window into the characteristics of the interstellar medium, revealing hints regarding the galaxy's genesis and development. For us, what does this mean? The voyage of Voyager 2 aids in our comprehension of the Sun's protective bubble and its interactions with the surrounding environment. This information helps scientists understand the universe outside of our solar system and is crucial for upcoming space missions. It's similar to locating the galaxy's neighborhood boundary and getting a glimpse of the cosmos beyond. The moment of crossing the heliopause was momentous. It demonstrated that Voyager 2 had formally entered interstellar space and exited the solar system. Despite being billions of kilometers away from Earth, Voyager 2 is still sending back useful data that helps us learn more about the interstellar medium. When Voyager 2 crosses the heliopause, it's like entering a new world and arriving at the solar system's edge. Its findings regarding interstellar space, cosmic rays, and the solar wind have altered our understanding of our role in the cosmos. Launched decades ago, this small spacecraft never ceases to amaze us with its amazing voyage into the unknown. Future exploration will be significantly impacted by the findings made by Voyager 2 at the solar system's edge. They offer a starting point for comprehending the interstellar medium and how stars, like our Sun, interact with it. Future missions like the Interstellar Probe, which intends to carry on Voyager's legacy by venturing farther into interstellar space, will be developed using these discoveries as a guide. Two pioneering spacecraft scientists have been able to better comprehend the boundaries of the solar system by comparing the data from Voyager 1 and Voyager 2. For example, the uneven form of the heliosphere was highlighted by the slightly different conditions that both spacecraft encountered when they crossed the heliopause. These variations imply that external elements, such as the local interstellar magnetic field and pressure, have an impact on the heliosphere. NASA launched Voyager 1 and Voyager 2 in 1977 with the goal of studying the outer planets and beyond. These spacecraft are considered to be among the most remarkable accomplishments in space exploration. We will discuss the similarities and differences between Voyager 1 and Voyager 2, emphasizing their complementary roles in advancing humanity's understanding of the solar system and interstellar space. Despite having nearly identical designs and similar missions, the two spacecraft traveled different paths and made unique discoveries along the way. NASA's ambitious Voyager mission included the 1977 launches of Voyager 1 and Voyager 2. Voyager 1 launched on September 5th after Voyager 2. 2 launched on August 20th. Voyager 1 reached its planetary objectives before Voyager 2 because it was launched later, but was put on a quicker trajectory. In order to explore several planets using gravitational slingshots, both spacecraft were built to capitalize on a rare alignment of the outer planets that happens about every 176 years. Jupiter and Saturn were the primary targets of Voyager 1, which produced groundbreaking information and pictures of these gas giants and their moons. The comprehensive study of Jupiter's Great Red Spot and the active volcanoes on its moon Io, the first proof of volcanic activity outside of Earth, was one of its most well-known findings. Voyager 1 investigated Saturn's complex ring system and Titan, its largest moon, whose thick atmosphere was of significant scientific interest. Voyager 2, the only spacecraft to date to examine these ice giants up close, had a more extensive planetary mission that included visits to Uranus and Neptune, in addition to Jupiter and Saturn. 10 new moons were found by Voyager 2, which also revealed Uranus's skewed magnetic field. It discovered the solar system's fastest winds at Neptune and took breathtaking pictures of the planet's deep blue atmosphere. In order to investigate the interstellar medium, Voyager 1 was steered higher and out of the solar system's plane after completing its flybys of Jupiter and Saturn. On the other hand, Voyager 2 proceeded to investigate Uranus and Neptune by continuing its journey through the solar system's plane. The two spacecraft were able to offer complementary viewpoints on the outer solar system and beyond because of their divergent paths. Eventually, both spacecraft passed through the heliopause, which is the line separating interstellar space from the Sun's influence. In August 2012, Voyager 1 became the first artificial object to enter interstellar space after successfully navigating through the heliopause. Its departure from the heliosphere was confirmed when it noticed a sharp decrease in solar wind particles and an increase in cosmic rays. November 2018 saw the launch of Voyager 2. In contrast to Voyager 1, Voyager 2 was able to detect plasma density directly since its plasma instrument was still operational at the time. Scientists were able to learn more specific details regarding the change from the solar wind to the interstellar medium because, to this, the same set of instruments, including as cameras, magnetometers, and plasma detectors, are carried by both Voyager spacecraft. But with time, these instruments' modes of operation change. In order to save energy for its other instruments, Voyager 1's cameras were switched off following its planetary mission. Consequently, it was unable to take pictures of its interplanetary flight. Since Voyager 1 was unable to measure the density and temperature of interstellar plasma directly, Voyager 2, with its plasma instrument in operation during its heliopause crossing, supplied vital information. The golden records, which are phonograph records with sounds and pictures that symbolize the variety of life and culture on Earth, are carried by both spacecraft. In order to communicate with any extraterrestrial species that could come into contact with the spacecraft, these records were created as a kind of time capsule. Despite being identical, both records represent humanity's curiosity and hope for connections outside of our solar system. Our knowledge of the solar system and interstellar space has been revolutionized by Voyager 1 and Voyager 2 taken together. From the structure of the heliosphere to the dynamics of planetary atmospheres, their data has helped scientists make many discoveries. As they continue to function well beyond their anticipated lifespans, they also represent human ingenuity and the spirit of exploration. Although they have traveled distinct routes, the twin spacecraft Voyager 1 and Voyager 2 are both dedicated to exploring the universe. Voyager 2's extended planetary mission and operational plasma instrument have offered unique insights into the outer planets and the border between the solar system and interstellar space, even though Voyager 1 was the first spacecraft to traverse interstellar space. Collectively, they have given humanity a better knowledge of our position in the cosmos and motivated countless generations of scientists and adventurers to keep aiming for the stars. The pressure on Voyager 2. For more than 40 years, Voyager 2 has been exploring the universe and providing groundbreaking information about the solar system and beyond. Voyager 2 continues to transmit important data from billions of kilometers distant, even after its historic planetary encounters and entry into interstellar space in 2018. Almost unthinkable, billions of miles. Scientists are optimistic about what Voyager 2 will uncover as it continues its journey into interstellar space, despite its age and distance. These are some of the main scientific objectives and expectations related to this amazing spacecraft. The mapping of interstellar space in detail comes first. Scientists are eager to study the characteristics of the interstellar medium or the material that fills the vast space between stars, as Voyager 2 ventures farther into interstellar space. Voyager 2's instruments are especially suited to investigate the density, temperature, and composition of this medium, which is made up of interstellar dust, plasma, and cosmic rays. By comparing data from Voyager 2 with its twin, Voyager 1, researchers may develop a more detailed picture of the interstellar environment and how it interacts with the heliosphere. Experts seek to better comprehend the heliosphere's form and behavior. The heliosphere, the bubble-like zone formed by the sun's solar wind, protects the solar system from many cosmic rays and interstellar particles. The voyage of Voyager 2 offers a unique chance to investigate the behavior and evolution of the heliosphere. The shape of the heliosphere, which seems uneven based on Voyager 2's measurements, is of special interest to scientists. Models of the interactions between the heliosphere and the interstellar medium can be improved with the use of ongoing measurements of the solar wind and interstellar particles. The ability of Voyager 2 to monitor the interstellar magnetic field is one of its main accomplishments. Researchers anticipate that the spacecraft will yield additional information about the behavior of this magnetic field far from the Sun. Understanding the larger galactic environment and how magnetic fields affect the motion of charged particles, such cosmic rays throughout the galaxy, depends on this knowledge. Voyager 2's mission places a lot of emphasis on cosmic rays, which are high-energy particles that come from supernovae and other astronomical occurrences. Because the spacecraft is in interstellar space, the Sun's magnetic field cannot interfere with its ability to measure cosmic rays. Researchers want to know more about the origins of these particles, their motion through space, and how the heliosphere protects against them. This study may shed light on the dynamics of our galaxy and the life cycles of stars. Additionally, interstellar dust particles, remaining pieces of old stars that aid in the creation of new stars and planets, can be studied by Voyager 2. By examining these particles, scientists can acquire a deeper understanding of the building blocks of the galaxy. By providing hints about the processes that shape our universe, Voyager 2's observations can assist in addressing problems regarding the distribution, size, and composition of interstellar dust. Future interstellar mission planning continues to be informed by the data gathered by Voyager 2. Voyager 2's discoveries will be expanded upon by the Interstellar Probe, a projected spacecraft that is intended to travel far further than Voyager. Voyager 2 establishes the foundation for new technologies and scientific goals in the exploration of deep space by conducting a more thorough examination of the interstellar medium and the heliosphere's edge. The potential for the unexpected to be revealed by Voyager 2's voyage is among its most thrilling features. Voyager 2 has consistently exceeded expectations, from finding active volcanoes on Jupiter's moon Io to identifying the unexpectedly high density of interstellar plasma. Scientists are nevertheless open to the prospect of new occurrences as it ventures farther into unexplored area, whether they have to do with particle behavior, cosmic architecture, or interstellar physics. Beyond its scientific goals, Voyager 2 offers important insights into engineering and the resilience of spacecraft in harsh conditions. With its power and instruments gradually declining, scientists are using Voyager 2 to test how long a spacecraft can operate and communicate in deep space. These lessons will undoubtedly inform the planning of upcoming missions that seek to conduct even more exploration. Voyager 2 has the potential to reach areas affected by the stellar winds and magnetic fields of other stars as it moves deeper into interstellar space. In order to gain understanding of how stars interact on a galactic scale, scientists believe that Voyager 2 may eventually find evidence of these nearby influences. The voyage into interstellar space by Voyager 2 is far from over. The shape of the heliosphere, cosmic rays, the interstellar medium, and the secrets of the galactic environment are all topics of great interest to scientists. Despite its age and the immense distance from Earth, Voyager 2 continues to push the boundaries of human understanding, delivering a view into regions of space never before explored. Voyager 2 continues to be a monument to human ingenuity and curiosity as it explores the unknown, encouraging subsequent generations to explore the cosmos even further. Voyager 2 helped us learn more and more about the final 3 planets in the solar system, which are the furthest from the Sun. It is the only spacecraft that has made close encounters with all 4 of the gas and ice giants, Neptune, Uranus, and Saturn. Despite not visiting Pluto, Voyager 2's findings at these far-off planets helped to shape our knowledge of the solar system by revealing important details about their atmospheres, moons, magnetic fields, and other features. In August 1981, Voyager 2 arrived at Saturn, expanding on the discoveries made by Voyager 1 before it. It revealed important details about Saturn's intricate moon, ring, and magnetic environment. By identifying spokes, gaps, and braided patterns inside Saturn's rings, Voyager 2 demonstrated their complex structure. These results implied dynamic processes, including particle clumping and dispersing and gravitational interactions with moons. The spacecraft's thorough observations of Saturn's atmosphere showed bands of clouds formed by strong jet streams and high winds surpassing 1,800 kilometers per hour. Enceladus, one of Saturn's moons that Voyager 2 spotted, showed signs of resurfacing processes, suggesting possible geological or possibly cryovolcanic activity. Later missions investigating the possibility of life on Enceladus were made possible by this discovery. It verified Saturn's powerful magnetic field and how it interacts with the planet's moons and rings to produce distinctive auroras. Let's move on to Uranus and see why it is known as the tilted ice giant. Voyager 2, which passed by Uranus in January 1986, is still the only spacecraft to have done so. Its findings showed Uranus to be an odd and enigmatic planet. Uranus's severe axial tilt of 98 degrees, which causes the planet to practically roll on its side as it orbits the Sun, was confirmed by Voyager 2. Because of its unusual orientation, it experiences harsh weather and seasons. A frigid, featureless atmosphere primarily made up of hydrogen, helium, and methane was found by the spacecraft. Uranus is pale blue-green because of the methane. Voyager 2 saw various weak weather patterns, such as faint banding and minor storm systems, despite its uninteresting look. Voyager 2 found that Uranus has a very uneven magnetic field that is inclined and offset from its center. Existing models were called into question by this peculiar magnetic pattern, which also implied a distinct interior structure. The complicated satellite and ring system of Uranus was highlighted by Voyager 2's discovery of 10 new moons and 2 more rings. Massive gorges and indications of previous geological activity were among the striking surface characteristics discovered during its investigations of moons like Miranda. The last time Voyager 2 visited a planet was during its flyby of Neptune in August 1989. It revealed fascinating insights into this faraway active world. Voyager 2 discovered Neptune's stunning blue color, generated by methane in its atmosphere. Strong storms, such as the Great Dark Spot, a huge storm system the size of Earth, and some of the solar system's fastest winds, which may exceed 2,100 kilometers per hour, were found. Neptune's magnetic field was discovered to be slanted and offset from the planet's core, much like Uranus, indicating that ice giants share this trait. Voyager 2 discovered Neptune's feeble ring system, confirming the existence of arcs or clusters inside the rings that contradict the smoothness seen in Saturn's rings. The largest moon of Neptune, Triton, was photographed by the spacecraft, which showed active geysers spewing nitrogen gas. Triton may have been a captured object from the Kuiper Belt, providing hints about the outer regions of the solar system, based on its geological activity and retrograde orbit. Let's move on to a lost chance, ex-planet Pluto, removed from the list. Because flybys of the outer planets were prioritized on Voyager 2's trajectory, Pluto was not visited. Pluto was regarded as the 9th planet when the mission was planned, but not much was known about it. Pluto was revealed to be a complex planet with mountains, glaciers, and a thin atmosphere by the New Horizons mission in 2015, which would provide detailed images and data about the planet decades later. Despite not visiting Pluto, Voyager 2's findings of Triton offered a sneak peek at the icy far-off objects in the Kuiper Belt, which includes Pluto. Voyager 2's observations of Saturn, Uranus, and Neptune revolutionized our knowledge of the outer solar system. It demonstrated the intricacy of magnetic fields, the variety of planetary atmospheres, and the dynamic character of moons and rings. The James Webb Space Telescope and planned missions to Uranus and Neptune, which seek to investigate these ice giants in greater detail, are examples of current and upcoming missions that are still guided by its results. By exploring Saturn, Uranus, and Neptune, Voyager 2 gave humanity a unique perspective on the outer solar system. The spacecraft revealed secrets that continue to motivate scientists and pique our interest in the universe, from Saturn's brilliant rings to Uranus's twisted enigma and Neptune's violent storms. Despite not going to Pluto, its findings set the stage for further research into frozen worlds near the solar system's periphery. By expanding our understanding of our location in the universe, Voyager 2 continues to stand as a testament to human inventiveness. Beyond expectations, picture the spacecraft that was constructed a few decades ago and is still in existence after 46 years. Voyager 2 is an example of both human brilliance and superior engineering. Designed to investigate the farthest planets of the solar system and beyond, Voyager 2 has long exceeded its initial mission constraints. It did, and it continues to relay crucial data from interstellar space more than 46 years after its launch. Voyager 2 was developed with durability and adaptability in mind, packed with cutting-edge equipment meant to resist the harsh environment of deep space. Built to tolerate severe conditions, Voyager 2 was meant to survive powerful radiation near Jupiter, the chilly emptiness of space, and the huge distances it would travel. Its sturdy frame safeguarded its scientific instruments throughout its journey. Voyager 2 produces power using a radioisotope thermoelectric generator RTG. By converting heat from plutonium-238's natural decay into electrical power, this method enables the spaceship to function far from the sun, where solar panels would not be useful. Over billions of miles, the spaceship can communicate with Earth because to its high-gain antenna. Through NASA's Deep Space Network, Voyager 2 stays in touch, even though its present distance causes signal delays of more than 18 hours. 10 scientific instruments, such as cameras, spectrometers, and plasma detectors, are aboard Voyager 2. The purpose of these equipment was to investigate the interstellar environment and the outer planet's atmospheres, magnetic fields, and moons. Redundancy was incorporated into several of Voyager 2's systems to guarantee that backups would be accessible in the event of a failure. This has been essential to keeping it operating for decades. One of Voyager 2's greatest accomplishments is its longevity, which far outstripped the 12-year mission period. Its long lifespan can be attributed to several factors. For more than 40 years, the RTG has been a reliable source of electricity, but its efficiency is progressively declining. By prioritizing power for critical systems and turning off non-essential components, NASA engineers have managed this decline. The components of the spacecraft were designed to endure prolonged exposure to the harsh conditions found in space. Despite decades of operation and the difficulties posed by deep space radiation and temperature extremes, its instruments and systems have remained reliable. As Voyager 2 ages, NASA engineers have come up with innovative ways to solve problems time and time again. For instance, they have remotely reprogrammed the spaceship to avoid malfunctioning parts, maximize power efficiency, and prolong its useful life. Engineers decreased wear and tear by using fewer moving parts, which has extended the lifespan of Voyager 2. Instead of using mechanical controls, many of its systems use electrical ones. Even though Voyager 2 was launched in the 1970s, software upgrades have enabled it to carry out activities that were not initially planned. It has remained relevant as new scientific issues have emerged because of its versatility. In actuality, though, it has existed for about 50 years. Even though Voyager 2 is billions of miles away from us, it nevertheless faces difficulties. Overcoming difficulties has been a hallmark of Voyager 2's lifespan. Operating a spacecraft billions of kilometers from Earth poses special hurdles. As the RTG's power production declines, engineers have prioritized powering just the most vital instruments and systems. This meticulous power management has allowed the mission to continue far longer than predicted. The growing distance makes communication slower and weaker. To stay in touch with Voyager 2, engineers have increased the sensitivity of deep space network receivers located on Earth. Mechanical and electronic components degrade with time. NASA has depended on redundancy and innovation to cope for aged systems, including modifying software to bypass faulty components. Decades after its launch, Voyager 2 continues to bring back data about the interstellar medium, revealing insights into the space between stars that were impossible to get from within the heliosphere. The lifespan of the spacecraft has shown how important flexible and sturdy design are for space missions. Newer spacecraft like the James Webb Space Telescope and future interstellar explorers are using these lessons. The success of Voyager 2 has sparked plans for large-scale additional missions, such as investigation of outer planets like Uranus and Neptune, and suggestions for specialized interstellar probes. Voyager 2 is a testament to human ingenuity and curiosity as it continues its journey into interstellar space. Its engineering prowess and the tenacity of the teams in charge are demonstrated by its capacity to function for decades under the most trying circumstances. Voyager 2's legacy will live on, encouraging future generations to push the limits of discovery, even though its power supply will eventually run out. For more than 40 years, Voyager 2 has been able to surpass its initial mission objectives and continue exploring the unknown thanks to its incredible technical and technological capabilities. The inventiveness of its founders and the commitment of those who have overseen the mission throughout the years are responsible for its longevity. Voyager 2 continues to be a shining example of human accomplishment as it ventures farther into interstellar space, proving what is achievable when scientific aspirations and superior engineering are combined. The search for meaning in the cosmos. Voyager 2 poses important queries concerning the nature of the cosmos and our position in it as it ventures into the interstellar medium. What is outside the solar system's borders? Is there other intelligent life out there, or are we alone? Even while Voyager 2 may not have the answers to these issues, its mission encourages us to look for them. Its investigation highlights our close ties to the cosmos and serves as a reminder that humans share many of the same elements as the stars. Voyager 2 challenges us to consider the significance of our place in the universe and the purpose of life by traveling so far from Earth. In addition to being a technological marvel, Voyager 2 is a powerful representation of human curiosity, inventiveness, and our quest for knowledge about the cosmos. Voyager 2 challenges us to reflect on our place in the universe, our common humanity, and the never-ending pursuit of knowledge as it travels into interstellar space and beyond the solar system's limits. Let's quickly examine Voyager 2's philosophical effects on humanity, emphasizing how it has influenced our outlook on life and motivated successive generations to consider possibilities beyond our planet's boundaries. Humanity is given a humble perspective on its place in the universe by Voyager 2's journey into interstellar space. The spacecraft's photographs of far-off planets, moons, and even Earth have highlighted how big space is and how little our world is in the overall scheme of things. By highlighting humanity's shared fate as occupants of a limited, fragile world, this viewpoint pushes us to think beyond national or cultural boundaries. Voyager 2 is a representation of humanity's unrelenting quest for knowledge. We had no idea what it would uncover when it was launched into space, but its findings have revolutionized our knowledge of the universe and the solar system. This readiness to explore the unfamiliar reflects a basic human quality: curiosity. The video ends, but Voyager 2 is not. It will reach new heights and uncover more solar system mysteries. See you at the following one.